All right, guys, listen up here. So you don't know quiz today. Okay, we covered that yesterday. What we are going to do is go right back into the acceleration stuff. So yesterday we talked about what acceleration is, okay, that it's a change in velocity over time, that it's the slope of a line on a velocity time graph, okay, those kinds of things. And then we looked at the 4 other formulas, other than the one we used in Science 10 last year, that we're going to use. What we're doing today is going over the use of each one of those 4 formulas. Okay, so we'll do some practice examples for each formula. I'll show you the manipulation of all the formulas. Okay, we'll get a little practice with that. We'll probably work on acceleration today and tomorrow. Look at doing a lab early next week. Okay, and then moving on to projectile motion so that we can finish up the unit with time for review by March 14th when your unit exam will be. Okay, everybody with me there? All right, other reminder, that vector assignment that we started on Tuesday and worked on again yesterday, that is due March the 5th. All right, so make sure you have that ready again because that one's on paper. Just bring it to me at the start of class. I had people looking for me at 8:30 a.m. trying to hand in their math assignments, which is great, but if it's on paper, you can give it to me in class. It's the Google Classroom lab reports, things like that have to be in at 8:30. Okay? All right. I want you guys to copy down this example here. We're going to be looking at the next acceleration formula on the list there. All right, so for this example here, we have a cattle train that is traveling west at 16 meters per second. What does it seem like they might have given me there?
Speed.
Okay, which one? Initial or final?
Your initial.
Probably initial, yeah. And I'd say it's probably velocity since they mentioned it was west. Okay? But yeah, it's definitely initial. Okay? Whoop. Wrong marker. All right, so we're going to have VI is 16 meters per second west. Okay? And then it says it's brought to rest. What did they give me there without giving me an actual number?
Velocity final.
Right,
0.
and it's 0, right? They gave me the final velocity and it's 0. So this is one of those, again, where I was saying before, a contextually important clue within the question. Now, before I even read any further, there's another important contextual clue here, okay, that is going to be important for me. These cattle are doing what? Speeding up or slowing down? They're moving at 16 meters per second and are brought to rest.
Slowing down.
They're slowing down. Okay? So if they were moving west, what direction is their acceleration? East. Okay? These are the little tiny details that are so important to get from a question. You get that by doing more of them and you gain experience with reading them. Okay? So they want us to find the displacement, okay, of the cattle train while coming to a stop, okay, and it takes 8 seconds for them to come to a stop. Now, we just said their acceleration is east. They don't even give us that in the question. We're not even going to need the number for the acceleration for this one. But here's the other thing that's important. They're moving at 16 meters per second west. They're brought to rest by accelerating east. Which direction will their displacement be?
West.
West. Okay? Think about it this way. I'm moving this way at 16 meters. Well, I'm not going to move at 16 meters per second. Even in my best years, in my prime, I probably couldn't move that fast. Okay? But let's say I'm going this way, okay? And I start to slow down. Am I still moving this way?
Yeah.
I am. I'm accelerating that way. That's how I slow down. But I'm still moving this way. Okay? These are the little things that we, again, have to get. I'm going to say that over and over again today. Okay? But these are the little things that come out of a question that are going to be important. I know my displacement is going to be west if I come to a stop. Okay? Now, if my final velocity was something east, then I might have a displacement east, but it doesn't. That's not the case in this one. Okay? All right. So these are my givens, and I'm looking for D. Which of the formulas on my formula sheet in the kinematics section has VF, VI, D, and T in it. Okay, this is like probably the most important skill when it comes to acceleration and projectile motion problems, is picking the right formula with your set of givens. Okay, I would say that this formula here has all of those things in it. Okay, would you agree? VI, VF, T, D, and they're all in. And lucky for me, it already solves for D. I don't even have to manipulate it on this one. I can just plug numbers in. That's always nice. Okay, so now that I know which formula I'm going to use, okay, I'm going to plug in my numbers. VF was 0. VI was 16. Okay, divided by 2. And the time was 8 seconds. All right, well, I think I can do that math in my head. 16 divided by 2 is 8. 8 times 8 is 64. Everybody okay with that? All right, so that means then that the displacement of this cattle train is 64 meters west. Okay, that would be an easy one if I put it on a quiz to forget to put a vector. Okay. All right, everybody okay with how that one worked? Now, another key part of this question was this. We can only use this formula if this is actually outright stated. Okay? If the acceleration is slightly not uniform, that formula doesn't work. Okay? So it's not one we use very often, but if the question says assume uniform acceleration, it's probably this formula, because it's the only one that has to be true for. Okay, let's look at how we manipulate this formula. Okay, all the different ways we can change it around. So I've got D equals VF plus VI divided by 2 times T. Let's say I want to solve for T. What should I do?
Times both sides by T. Or divide, sorry.
Okay, if I divide both sides by T, I can do that, I can move it over, it's gonna be extra work, but, okay, if I divide it over here, doesn't it end up on the bottom? Can I solve for it if it's on the bottom? No, I mean, I could eventually, I'd have to flip a few things and do a bit of extra work. I could get there, but I like to do things the simple way. Can I move this? Can I move the whole brackets over to the other side altogether? Yes, I can. Remember, order of operations says you do what first?
Brackets.
Brackets. So this whole mess is like x times t. Okay, it's one number. It's not one number, but it effectively becomes one number, mathematically speaking. There is nothing wrong with me dividing that whole thing over to the other side and leaving t where it is, where I can solve for it. Okay, that's the simplest and quickest way to isolate t in this formula, is just to do this. Okay, it cancels off and it just comes over here. Okay, and now we're solving for t. Everybody all right with that? Okay. What if I want to solve for VI? Now what would I move first, though?
T.
T, yeah. Now I would definitely divide both sides by t. All right, so t comes over here. Oh, that's not what I want. Just wanted the t to go away. Okay, now that t is gone. Are the brackets necessary now? Nothing else over here now, right? So I'm just going to get rid of those. Now I can pick this thing apart. Okay, did I say VI? I said VI, right? Okay, so if I want to get VI by itself, what's the next thing I move? In that equation, what's not attached to VI?
The 2.
The 2. Yeah. If I want to isolate VI, the next thing to do is multiply both sides by 2. All All right, so I bring the 2 over there. I want VI by itself. What do I do with VF?
Subtract it.
Subtract it over to the other side. Okay, 2D over T minus VF equals VI. What if I wanted to solve for VF instead? Would I do the same thing except subtract VI? They're being added together. They're both positive, so I just subtract whichever one I'm not looking for, okay, and bring it over to the other side. Okay, everybody all right with that? You're gonna start flexing your algebra muscles here now. Okay, I mean, you did some trigonometry, okay, that's sort of algebra, but you're really gonna get going on the, I gotta manipulate this equation and solve for this thing, okay, now that we're dealing with acceleration. All right, I want you guys to try those 2 questions. I'll make it a little bit bigger here so you can maybe read it better. Okay, and I will remind you that we're dealing with vector quantities here, and that you have to represent vector quantities mathematically with positives and negatives. That's going to come into play especially in question number 2. Okay, so for number 1, we got a hound running at a velocity of 16 meters per second south, slows down uniformly to a velocity of 4 meters per second south. Which one of those is initial? Yeah, the 16 is the initial, okay, because according to the context of that question, it happened first. Okay, so 16 meters per second south, that makes the VF 4 meters per second south, okay, and it does that in a time of 4 seconds. Okay, we're looking for the total displacement. So once again, I don't have to manipulate the formula here, it's already solving or set up to solve for D. So D is going to be final velocity plus initial velocity divided by 2 times time. All right, so that's going to be 4 minus 16, okay, divided by 2. So, okay, 4 minus 16 should give me negative 12, right? Sorry, that's times 4. Negative 12 divided by 2 is negative 6, okay, times 4. Oh, sorry, why am I doing subtraction? Why is that coming out negative? Sorry, 20 divided by 2 is 10, times 4 is 40 meters. Sorry, guys, 40 meters south would be my total displacement there. Sorry, I don't know why I was subtracting on that. Okay, everyone okay with the first one? How many people have done the second one? Now, on the second one, direction's really important. A ball is moving up a hill with an initial velocity of 3 meters per second. Okay, here's like the most terrible thing you can do in a question. F-O-U-R. How many significant digits in F-O-U-R? Hell if I know. Okay, if you don't write it as a number, how do I know how accurately you measured it? Okay, you should never write a number as a word in physics. Okay, we're going to assume it's 4.0. Okay, just because that's absolutely, it's one of the reasons we don't use the textbook very much. Okay, 4.0 seconds. Okay, it is moving down the hill at 9 meters per second. Okay, what's the displacement? All right, so once again, I don't have to manipulate, but before I get started doing the math, what should I know already about the displacement of this object? Which way is it going to be? Uphill or downhill? Downhill. It's going to be downhill. It was only moving up the hill at 4 meters per second. At the end of this thing, it's moving down the hill at 9 meters per second. The acceleration on a hill is uniform. It's constant. If it ends the question going faster down than it started going up, it's moving down. Okay? And it's going to be displaced down from its starting position. Okay? So when I do the math, it's going to come out that way. Okay? So we're going to have D equals, okay, VF plus VI over 2 times T. When I plug in my numbers, that's going to be -9. I'm going to make downhill negative, right? Plus VI, which was 3 meters per second up the hill. And then I'm going to divide that by 2. Okay? And then I'm going to multiply by time, which was, FOUR seconds. Okay, so -9 plus 3 is -6. -6 divided by 2 is -3. -3 times 4 is -12. Should I leave my displacement like this? What should I write instead of negative? What did the question give me?
Downhill.
Downhill. Question gave me up the hill and down the hill. I converted up the hill and down the hill into positive and negative so I could do math, because I can't plug uphill into my calculator, right? But I have to go back to the vector the question gives me when I finish. It's another thing that this question got wrong in the textbook. Okay? We don't use negative for downhill. And I need to write downhill. Why wouldn't I write down? Are down and downhill the same thing? They're not. Down means you're falling through the hill. Maybe someone dug a hole. Okay? Down the hill means you're going down the hill. They are two different things. I know that seems really picky, and it is, but they aren't the same. Okay? Just so we're aware. Okay. Any questions on those? So that's that formula. Okay? All right. Write this one down. This is for our next formula. So if I'm reading this one through, I've got a golf ball that's initially traveling at 25 meters per second. Okay? Now they don't give me a vector on that, but I see later on in the question they have something labeled as negative. So I have to assume that this is probably positive. Otherwise they would have outright said it was negative, right? And if we think of the context of a question, if a ball is moving forward and it hits sand, it's going to slow down. And slowing down means the acceleration is negative in the other direction. Okay, these are little contextual things I have to get out of the question. Right, visualizing it is so important, as we talked about the other day. Okay, so VI is going to be positive 25 meters per second. Okay, it hits a sand trap and it accelerates at negative 20 meters per second squared. Okay, find its displacement after 2 seconds. All right, do I have a formula on my formula sheet that has D, VI, A, and T in it? What would it be? It's one of those ones that's the graph area under the graph formulas. I'll give you a hint, starts with D. What's the next thing after the equal sign?
VI.
Okay, so VI times T plus 1/2 AT squared. Okay, now T is in 2 places in that formula, so we have to use it twice. Okay, but we are looking for D in this particular question, which means no algebra for this one. We're just plugging in numbers. Okay, so we'll have our initial velocity, 25 times 2 seconds, plus 1/2 times the acceleration, negative 20. How often do you suppose people forget to put that in there? Let me tell you. I put a question like this on every unit exam. At least 1/3 of people will forget to make that acceleration negative, even when I tell them it's slowing down. Okay? context visualization is important. Okay, times 2 squared. All right. How many questions have we done? I haven't even fired up my calculator yet. That's dangerous. Do you know that math in my head? Okay, so the thing to remember about this formula here, guys, we talked about this the other day. If I'm looking at a velocity versus time graph, okay, of an object that is accelerating, okay, essentially this is calculating, okay, the first part's calculating the rectangle, the second part's calculating the triangle. Right, so we got 25 times 2, so that's going to be 50, okay, plus 1/2, so 50 plus 0.5 times negative 20 times 2 squared. Okay, so the displacement of this golf ball is going to be 10 meters. Now it came out positive. Should I put positive on it? I would. It asked for displacement. I got to put some kind of vector on it. Okay, you could even write forwards within the context of the question. That wouldn't be wrong. Okay, it doesn't outright say forwards, but we could assume it. Okay? So 10 meters forward or positive 10 meters, and either one in that case would be acceptable because we weren't told either one. Okay, manipulations of this formula are tricky. Okay, so here's some things we need to look at for this one's manipulation. First off, let's say I wanted to solve for VI. What should I move first? What's not attached to VI right now?
Subtract the 1/2 times a times t squared.
Yeah, I can take that whole thing over to the other side. Remember, order of operations says I would find out what 1/2 at squared is before I would add it to whatever VI times t is. So I can subtract this whole part of the equation over to the other side together. Okay, so d minus 1/2 at squared equals VI times t. All right, I want VI by itself. What do I do with t? Divide it over to the other side. Okay? Okay, now here's where sometimes people make a mistake. I got t squared on the top and t on the bottom. Do they cancel? Not in this situation. Okay? If the whole top was all being multiplied together, then yes. But there's a subtraction operation in there, so no. All right? So now, okay, I've manipulated for VI. Okay? That's one of the actual easier manipulations for that formula. Okay. All right, let's look at, how would I manipulate that for A? What should I move first?
VI and t.
Okay, I should subtract VI times t over to the other side. Okay, so I'm going to have D minus VI times t equals 1/2 at squared. I want a by itself. What do I do with the half and the t squared?
Divide them.
Divide them over to the other side, right? That's the opposite. They're being multiplied all together. Okay, now I'm solving for A. Okay, so there's, like I said, you're going to have to flex your algebra muscles here a little bit. All right. Now, how do I solve for t? That was trickier.
Subtract the 1/2 at squared.
Okay.
And divide VI.
Okay, but that's going to leave a t squared on the other side. T's in two places. Does that make this tricky? It does. Makes it so tricky that you'll want to use the F word. Factor. You were thinking something else, but it's factor. Okay? Okay, we would have to factor this if we wanted to get T by itself, because T is in two places. Hey, you want to know some good news? You don't have to factor in physics. That's a math thing. Okay, so using this formula, at least in physics 20, okay, and physics 30 as well, okay, you will not have to solve for T if VI is not 0. You may have to solve for it if VI is 0. Okay? Because if VI is 0, how does that change the formula? What's 0 times T? 0. So if VI is 0, that whole part of the formula goes away. Now T is only in one place, and you can solve for it, right? You would solve for it by dividing both sides by half of A, and then square rooting so that T is by itself. Okay? So with that formula, you won't have to solve for T unless VI is 0. Okay? All right. Questions on that formula there? Okay. Here's 2 questions that use that formula. Give them a try. Okay, so for our first one, we got a skier moving down a uniform slope at 3 meters per second. That sounds like an initial velocity to me. Okay, so 3.0 meters per second downhill. Okay, the acceleration down the hill is 4 meters per second squared. Okay, find the skier's displacement after 5 seconds. Okay, so we're using the same formula here, okay, and we don't even have to manipulate it because it's already set up to solve for D. Okay, we just have to plug in our numbers. Now, I have downhill in here, and I had a good question. Someone asked, do I need to make that negative? And the answer is no. Downhill only needs to be negative if some other part of the question is uphill. There's a change in direction, okay, then you need to have positives and negatives. In this case, the person's only going downhill. Downhill can be positive. Okay. All right, so D equals VI times T plus 1/2 AT squared. We're just plugging in our numbers here. So 3 times 5 plus 1/2 times 4 times 5 squared. All right, and that should give us 65 meters, but not down, downhill. Yep, okay, another of the many mistakes in this textbook, okay. When we originally bought full class sets of the textbook, it had so many mistakes in it that we called the publisher and said, this is stupid. There are so many mistakes in here. And they said, that's okay, you can buy our corrections manual. I'm like, so we bought your book, and now we have to buy the book that has all the corrections for your crappy book? No. We sent them all back. Yeah. Okay. So if we're looking at the next one here, okay, motorcycle traveling at 100 kilometers per hour. So we're going to divide that by 3.6. 27.7 repeating? Yeah? Or is it 26.7?
26.6.
26.6 repeating. Okay. So VI is 26.6, okay, repeating meters per second. Okay. Applies the brakes at 0.8 meters per second squared. What do I need to know about applying the brakes?
Actually, going to correct myself. It was 27.
It was 27. It's okay. I'm used to being wrong.
Yeah.
So yeah, I just assume it
Yeah,
most
I
of the
gotcha.
time. It's safe. Yeah. So 27.7 repeating. Is that right? I'll plug it into the calculator in a minute. I'm just being lazy. Okay. If I apply the brakes, what kind of an acceleration does that produce? Positive or negative? Oh my God. How many of you have driver's licenses? What do the brakes do?
Slow you
They
down.
slow you down. What kind of an acceleration is that? Positive or negative? Thank you. Okay. Yeah. All right. So our acceleration is negative 0.8 meters per second squared. Okay. It's a contextual thing within the question. I give a question like that, and I will catch a whole bunch of you who will just make that 0.8, and then your answer won't make sense because it will say you went faster, even though you applied the brakes. If your brakes make you go faster, you're in real trouble. Okay. All right, and then we have a time of 60 seconds, another thing we have to convert so that our units match, okay? And we're looking for D. So we're just plugging in our numbers again here, okay? We're gonna have 27.7 times 60 seconds plus 1/2 times negative 0.8 times 60 squared. All right, when we do that, we should get 2.3 times 10 to the 2 meters. Okay, and I don't need a direction on that one. Why? What did the question ask for?
That's for distance, not displacement.
Right. It said how far. How far is distance. How far and in what direction is displacement. Okay, because they didn't use outright the word displacement and never asked for direction. How far means distance. That's why I can get away with no direction on that 2.3 times 10 to the 2. Okay, questions on those two? Okay, so obviously we'll have questions where we have to manipulate that formula. These two examples we didn't have to. All right, write that one down. Do this question about the boat here in a minute. Okay. So if we're looking at this question here, it says a speedboat slows down at 5 meters per second squared. So that 5 meters per second squared, positive or negative? Negative. Okay? It has to be. It's slowing down. It was moving forwards and it slowed down. Okay? So here's what we know to start off with. Our acceleration is negative 5.0 meters per second squared. It comes to a stop. What did they give me?
Final velocity.
Final velocity, it's 0. Okay, VF, 0 meters per second. Okay, that takes 15 seconds, so that's time. Find the displacement. Okay, similar data set to what we had for the last question, except this time we got VF instead of VI. Can we use the sister formula to the other one? The other one was D equals VI times T plus 1/2 AT squared. Now we're going to say D equals VFT minus 1/2 AT squared. Okay, so we're just using the other version of that formula. So VF times T minus 1/2 AT squared is the formula I've got to use here. Now, the givens in this question make this a little bit easier for me, in as much as VF is 0 in this question. So what's VF times T? 0. Okay, if VF is 0, anything times 0 is 0. Okay, so I'm going to have 0 minus 1/2 times negative 5 times, what was the time? 15 seconds, 15 squared. Why is it important for me to include this and not just go, if I cancel off the VF times T and just pretend it's not there?
Because you're subtracting the second part from the first part, so you need the first part.
Right. I need that first part in there. Otherwise, I might just go 1/2 AT squared and forget about the minus that's there, and that will affect my vector. Okay? I'm going to be subtracting a negative number. Think about it this way. If I don't do that, it'll tell me my displacement is backwards. The last time I checked, slowing down doesn't make me go backwards. It makes me accelerate backwards, but it doesn't make me go backwards. Be thankful, because then applying your brakes would make you go backwards, okay? Which would cause all kinds of traffic problems. Okay? So in this boat, okay, I'm still going to have a displacement that is positive, that is forwards, because that's what a boat would do if it was slowing down. it would still be going forwards. Okay? So D equals, sorry, we got the numbers in there already. Okay, so punching those in, 0 minus, okay, 0.5 times negative 5 times 15 squared. Okay, gets me a positive number. Goes a long way, but it means traveling for 15 seconds. Okay, so we've got 5.6 times 10 to the 2 meters. And that would be positive because that's all they gave me. Everyone all right with that one? Okay. Now, if we're looking at manipulations, it's the same as the other formula. Okay, D equals VF times T minus 1/2 AT squared. If I want to solve for VF, I'll add the 1/2 over 1/2 AT squared. That would equal VF times T, and then I would just divide both sides by T. Okay, it would come over, same as we did with the other formula. Okay, if I want to solve for A, then I would subtract. Okay, actually what I would do is add the AT squared over here. So I would have D plus 1/2 AT squared, then I would subtract the D. Okay, so I would have VF times T minus D equals 1/2 AT squared, and then I would divide, okay, the half and the T squared over to the other side. That keeps it positive. Okay, that's the only reason I would do that, is it keeps it positive. All right, and then you won't be asked to solve for T unless VF is 0. Okay. All right, well, let's have you guys try a few questions to do with that one. Okay, you got the Top Gun question for the first one. Okay, so the arresting device on an aircraft carrier stops a plane in 150 meters with an acceleration of negative 15 meters per second squared. Okay, if you've ever seen any movies, okay, where these aircraft come in and they hit an aircraft carrier and they have to land, they have to have these arresting cables that go across the deck. Okay? They hit those cables, they catch them with this big hook that hangs off the back of the plane, and it literally jerks them to a stop violently. Okay? 15 meters per second squared is about 1.5 times your weight being thrown into your harness. Okay, so you would definitely feel that. Okay, so they're stopping the plane in 150 meters. It's actually a lot shorter than that. They don't let them go that far even. Okay, and the acceleration is in real life quite a bit more than that too. Okay, but that's the numbers we're given, so that's what we'll deal with. We know that the displacement is positive 150 meters because the plane keeps moving forwards. Okay, we know that the acceleration is negative 15 meters per second squared, and we are looking for the time it takes the plane to stop. Okay, so remember I said you wouldn't have to use this formula to solve for T unless VF was 0. Okay, so when I'm looking at this formula, I've got D equals VF times T minus 1/2 AT squared. All right, so I'm trying to solve for time. So the first thing I'm going to do is say, all right, I'm going to take this out, but I'm going to leave that negative there. Rather than leave a 0 in there, I'm just going to leave the negative in there. Okay? And I'm going to solve for T. So that means I'm going to have to divide both sides by negative 1/2 of A. And then do what? That solves for T squared. What do I want?
T.
Just T, so I have to square root. Okay, so I'll do a square root. Now I'm solving for T. Okay, so T will be the square root of 150 divided by negative 1/2 times negative 15. This is where the negative comes in important. If you forget one of them, your calculator is going to have a conniption fit when you try and enter this in because you can't take the square root of a negative number. Okay? So it's important to have all those negatives in there. Okay, when we punch that in, right, so we'll have the square root of 150 divided by negative 0.5 times negative 15. All right, 4.5 seconds would be our time. Okay, everybody all right with that one? So tricky manipulation on that one for sure. Okay, that one makes you flex your algebra muscles a bit. All right, and then our second one, okay, we've got the 68 Corvette took 6.2 seconds to accelerate to 160 kilometers per hour. That's 100 miles an hour. Okay, that's fast. That was a fast car back in 68, but it had a giant big block V8 in it too. Okay, that probably got, 1 mile per gallon, okay, when driving on the highway. So we would have a time of 6.2 seconds. We have, it's accelerating to this speed, so our VF is going to be 160 divided by 3.6. Okay, so 44.4 repeating. Okay, meters per second, and it travels 220 meters. Okay, find its acceleration. All right, well, we know that V equals VF times T minus 1/2 AT squared. So if I want to solve for A, okay, my first move would be to add the 1/2 AT squared over to the other side so that it's positive. Okay, then I'm going to subtract D from both sides. And then I'm going to divide by 1/2 of T squared so that A is now by itself. Okay, when I plug in my numbers, I'm going to have 44.4 okay, times 6.2, okay, minus 220 divided by 1/2 times 6.2 squared. Okay, when I do that, I should get 2.9 meters per second squared north, because everything in the question was given to me in north, even though I forgot to write that. Okay, everybody all right with that one? That's another tricky manipulation. Okay, there are some ones here that are going to be, algebra intensive for sure. Okay, anybody need that anymore? Okay. All right, we got one formula left, guys. Okay, so you write that question down and we'll go through this formula. All right, so we often use the formula that's going to be involved in this question with exactly this type of situation, a projectile. Okay, a bullet is a projectile, right? Bullets are fired or accelerated, okay, when the hammer of the gun comes forward and hits, okay, the casing where the gunpowder is. The gunpowder explodes, and the expanding gases are trapped within the barrel of the gun. So when they expand, they have no choice but to push the bullet along the length of the barrel, okay, accelerating it until they escape out the end of the barrel, okay, which usually produces like a muzzle flash, the thing you would see when someone shoots a gun, okay, that kind of stuff. And it's going to propel this bullet out the end of the barrel, okay. Now, are we talking about a huge acceleration? It's massive. Okay, we're accelerating a really small mass, mind you. A bullet is not terribly heavy, okay, but we're accelerating that incredibly small mass to a very high rate of speed in a distance about this long for a rifle. Okay, for a pistol, only about this long. That's why pistols don't fire bullets as fast. Okay, they don't get the same amount of distance over which to exert the force. Right, so we've got a bullet that's accelerating the length of the barrel of a gun, so that would be then the displacement, 0.750 meters. Okay, and the acceleration is, as we said, massive, 5.35 times 10 to the 5 meters per second. Okay, that's big. At what speed does it exit the barrel? So they're looking for VF. What's VI? 0. contextual clue, okay? It never said the person who fired the gun was running while they did it, okay? So we have to assume that everything was stationary and that VI would be 0. Little assumptions we have to make from the context of the question. Okay, so my last formula is the one that contains all of these and not time. It's the one formula involving acceleration that doesn't involve time. And that formula is this: VF squared equals VI squared plus 2AD. All right, so I'm looking for VF. Formula is already set up to calculate that, so I don't have to do any algebra with this one. Right? All I have to do, well actually I do have to do one little tiny bit of algebra. This solves for VF squared. What do I want? Just VF. So if I want to solve for VF, then I just have to do this. I just have to square root the other side. Okay? And then I'll get VF regular. All right? Now, VI is 0. So I'm just going to get rid of it. Don't need it in there. All I have to do is find the square root of 2 times 5.35 times 10 to the 5, okay, times 0.75 meters. Okay, so the bullet leaves the barrel of the rifle moving at 896 meters per second. Is that fast? It's pretty fast. Okay, here's something that will scare you. The speed of sound is 330 meters per second. If this gun were to be fired at you, would you ever know it? Unless they missed. If they missed, you'll know, because you'll hear the sound after the bullet goes by your head. Okay? This is the scary thing about like long-range shooting. The bullet travels faster than the sound of the shot. Okay? It's why in like basic training they'll often tell you, like, how do you know if you're being shot at? And they'll say a hiss means it's close. A snap means it's really close because it's actually the sonic boom of the bullet going by that you hear the snap of it. A hiss means it was a little further away and you just heard the sizzle, but you always hear the sound of the shot way later. Okay? If we're talking about like expert snipers, the longest sniper shot that was a kill shot in history was shot by a Canadian, and it was just under 4 kilometers. Okay, 4 kilometers away. That means that when the bullet hit its target, it was several seconds ahead of the sound of the shot. Okay? So if it was being fired at you and they missed, which is of course you would hope for, okay, you'd probably see the puff of dirt where the bullet struck the ground. And then 1, 1,000, 2, 1,000, 3, 1, bang! Okay? It's like when you figure out how far lightning is away from you, right? You see the lightning and you count how long it takes for the thunder to get there. It's like that. Okay? The sound travels slower than the light. Well, in this case, the sound travels slower than the bullet. You can rock yourself to sleep tonight with that thought. Okay? Yeah. All right, is that making sense? All right, let's look at real quick here while we still got time. Some manipulations of that formula. Okay, if I want to solve for VI, what do I move?
The 2AD.
Right, by doing what? By subtracting. So I'll have VF squared minus 2AD equals VI squared, but then I would square root, okay? And I would have that. That's the manipulation for VI. Okay? If I wanted to solve for A, what would I move first? Yep, move VI squared over by subtracting it. So I would have VF squared minus VI squared equals 2 times A times D, and then to get A by itself, divide by 2D. Okay, now A is by itself. If I wanted to solve for D, I'd divide by 2A instead. Okay. It's going to take a little bit of practice. That's what we're going to do tomorrow. Okay, practice some acceleration problem solving. And then, like I said, next week we'll be looking at doing a lab pretty early in the week. Okay, I will post a review package for that unit exam sometime middle to end of next week. Okay?